What we're going to do in this session is to focus on tools available to project professionals to enable them to do a better job in executing their projects. I work with a lot of technical people in IT and engineering professions and other technical areas, scientists for example, and especially younger people from these areas are really focused and excited about tools. They want to know what tools can we have to help us do a better job. So we're going to look at the broad area of tools that are available to us to be more effective in project management in this session. What I want to point out though, before we get into some of the detail, is that don't be naive. There's no questions that a carpenter who has a good set of tools is going to have a easier life of doing carpentry and may even do better carpentry than a carpenter who has a poor set of tools or inadequate tools. So the tools are important. But we also have to recognize there's a lot more to project management than mastering a good set of tools. As I've said in my initial session, a large part of projects has to do with the messiness of coping with Murphy's Law. A lot of the real issues of project management have less to do with tools. They have a lot more to do with how do I manage other people? How do I handle an angry customer? How do I motivate team members who don't want to be on my team because they have other things to do? Now, having said that, let's take a look at the very important area of tools. The tools are important. I'm going to talk now about the most general set of decision-making tools we have, which aren't necessarily project-specific tools, but they are tools that we teach in the decision sciences to help people make more effective decisions regardless of their line of work. You can be an office worker, you can be a manufacturing worker or a project worker, and these are key tools that you should have some sense of in order to enable you to make better decisions. Now let me step back a moment. For more than 25 years I've been a professor of management science, and management science is that part of management and operations research that's concerned with decision making. So in a sense, for more than 25 years I've been a professor of decision making, and I've worked with a lot of other management scientists over the years, with many management scientists. I was once a chairman of a department of management science where we had some 30 professors, all of whom were concerned with decision making. Now it's interesting, in this department of management science with its 30 professors, we took multiple perspectives on decision making. A certain portion of the professors viewed decision making from an organizational perspective. Many of them had PhDs in psychology, organizational behavior, group dynamics, and they examined decision making from the perspective of how do you get a group of people to come to a decision. So we used to joke they were the psycho-weenies of our department. Then we had other professors who approached decision making from a far more technical point of view. What are some of the tools and techniques we have for decision making? Famous tools like linear programming and multi-attribute decision making techniques and so on and so forth, statistics. We call those people the techno-weenies. So to a large extent, our department of 30 people reflected the multiple dimensions of decision making. It has a psychological component, an organizational component, it has a technical component that's closely tied to a set of tools that enable you to optimize things. Okay, so that's something important to recognize right away, that when we talk about decision making and being effective in decision making, we have to approach decision making from its different dimensions. Now, here's something that I've learned. I didn't know this before I became a professor of management science, and it was probably only several years into doing management science work that this occurred to me, and that is that all decision-making, all rational decision-making is a process of prioritization. Okay, process of prioritization. That means that when we make a decision, any decision, okay, a rational decision, it could be a decision at home, it could be a decision at the office, it could be a decision at what restaurant to go to tonight. Whenever you make a rational decision, what you are really doing is rank ordering things. Okay, you're prioritizing so that the things that are the most attractive go to the top of the list, things that are the least attractive go to the bottom of the list. So let me repeat then, that rational decision making is fundamentally a process of prioritization. Now, anyone who wants to use or to develop tools for decision making has to deal with that reality. Okay, one thing you have to recognize is if whenever you're making a decision, what you're really doing is rank ordering things, prioritizing them. So in selecting tools for decision making, make sure that these tools enable you to rank order, to prioritize things. Now, there are a whole range of techniques, hundreds of techniques for prioritization, and I don't want this presentation to be a technical presentation. As you can see, I don't have a whiteboard behind me where I can draw formulas and draw grids and things like that. So what I want to do here is to stick to the basic principles, okay, of prioritization with a few illustrations. Now, one approach to prioritization that everyone here should be aware of is using scoring sheets. Okay, with scoring sheets you identify various criteria for ranking something. Let's say we're talking about project selection. Project selection requires prioritization, doesn't it? So if we're talking about project selection, you can have a scoring sheet that lists, say, a dozen criteria that we want to use for measuring potential projects and their value, their worth. So one of the scoring sheet items might be something like cost. Now that one's easy to deal with. The cost can be, you can put into a ordinal range. You can say high, medium, low, or you can actually put in a dollar figure, and the dollar figure itself enables you to prioritize, to rank order. A $300,000 project is more expensive than a $200,000 project. So one of the criteria you can put into your scoring sheet would be something like cost, and most certainly that's important consideration when prioritizing projects. Another item might be something like nearness to the state of the art. Okay, how near, if we carry out this project, to what extent will it require us to use state-of-the-art, say, capabilities? And you can create a scale of 1 to 5. If the project entails really state-of-the-art types of activities, it gets a score of 5. If it's very routine, humdrum, standard type of undertaking, not near the state-of-the-art, it would have a score of 1. And if it's somewhere in between that, people can score either 2, 3, or 4. Okay. Other criteria that you can have for ranking the project is within our organization, on a scale of 1 to 5, do we have qualified people to do the job? So the idea here is to create various criteria that are important in determining, in our specific example, whether or not a given project should be supported, and identifying these criteria, creating a scale. I like to use scales of 1 to 5, and then when you have the scoring sheet developed, passing it out to, say, members of a project selection committee. And these members of the committee will, each of them sit down after they've heard about the project and read about it, and then they'll score it item by item. And if the score winds up being a very large number, a project that gets lots of 4s and 5s, That project will go, when you add up the total numbers, you'll see it's a big number. It goes to the top of the list. Projects that have a lot of low numbers, 1s and 2s and 3s, go to the bottom of the list. We choose the projects at the top of the list. Scoring sheets have been around a long time. They're very easy to implement. What it really requires, if you're going to have effective scoring sheets, in fact if you're going to have any effective decision making of any sort, it's important that the scoring sheets are handed to the right people, that we have the right people involved in the decision process. That's even more important actually than how did you structure your scoring sheet. Do we have the right people sitting in judgment filling out the scoring sheet? In today's decision making, when we talk about making decisions and prioritizing, we find that it's very important that whoever's making the decision, that it be some kind of cross-functional group. In the old days, when you were prioritizing projects, you'd always give it to the engineers or the technical staff, and of course they have their blinders on, their tunnel vision. They're assessing projects according to the technical merits. And then we go ahead and support the project, and it doesn't make it in the marketplace. Okay, nobody wants to buy this brilliant technical solution. So what we need to do then is to make sure that whoever is involved in the prioritization process, the people who fill out the scoring sheet, will reflect different aspects of the project and where it fits into our organizations and into our needs. So you certainly want someone, say, from marketing sales, who can assess the new project opportunity from the point of view of will it help us do our business better. You want someone from finance who can take a look and does this make sense financially? Do we want to spend $1 million on a project that might be able to generate $10,000 of revenue? Certainly the technical people from engineering, from IT, should have representation on the committee as well. So with something like scoring sheets, if they are delivered to the right set of people, you can quickly develop a sense of what are my internal experts, this cross-functional team here, what is their general sense as to the relative merits of these different projects that we're rank ordering. Another approach to prioritization, which is quite different from the scoring sheet approach, is to employ one of my favorite heuristics. A heuristic is a rule of thumb. Okay, we have lots of rules of thumb, and a heuristic enables us to come up with a quick decision-making tool that enables us to prioritize things quickly. And my favorite heuristic is the 80-20 rule. It's also known as Pareto's rule, named after Count Wilfredo Pareto, who was a very, very sharp economist, Italian economist, who was operating early in the 20th century. And the Pareto rule is a very simple rule of thumb that helps us to prioritize by forcing us to focus on a small set of important things that have a big impact. People in sales departments live and die with the Pareto rule. In sales departments, here's how they use the Pareto rule. They recognize that 20% of our customers generate 80% of our revenues. Okay, not all customers buy the same quantity of goods and contribute to revenues in the same proportion. A small number typically have the major impact. Now, how does that help you prioritize to make decisions? Well, clearly, customers that are within that 20% core group are going to get favorable treatment. Okay, they rank higher than customers who contribute 0.00001% to our bottom line. Pareto's rule is an important rule in quality management. In quality control, one of the ways we set about systematically trying to achieve zero defects as part of zero defects programs is to take a look at a process, and then let's say we want to improve the process. We want to have fewer errors, deviations from some requirement in the process. We want to narrow the band of variability, is the technical term. In order to fix the process, we can't fix everything. We don't have resources to fix every single source of variability. So what we want to do is to find the core sources of variability, the core sources of problems on our project that contribute most of the problems. Again, the 80-20 rule here. So what 20% of potential sources of problems actually create 80% of our problems? And we have a rule for prioritization. Which problems do we fix? Do we try to fix everything? No. We focus on the core 20% of sources of problems that lead to 80% of the problems. And if we fix those core 20%, suddenly we find that the upper and lower control limits of our variability charts, suddenly the upper and lower control limits get closer and closer together. We're able to have processes that have less variability. Round two, you look at the new control chart and you say, okay, let's find of the remaining sources of variability, let's find the 20% that contribute most of the variability, and you fix those. And you go through this process. Deming called it plan, do, check, act, the PDCA cycle. You go through this process, engaging in continual process improvement. And what are we approaching in terms of defects? We're approaching, we'll never achieve it, but what you're doing is gradually approaching zero defects. So again, we have a prioritization technique here called the 80-20 rule that enables us, if we use it as a rule of thumb, to prioritize things, identifying what things are the most important, focusing on those, dealing with those issues, and kind of not totally ignoring, but taking the other things, the residual, the trivial things, and putting them to the side. We don't want to have our attention all bogged down trying to deal with small issues when the big issues aren't being resolved. In project management, perhaps the most famous prioritization tool is called benefit-cost ratio analysis. With benefit-cost ratio analysis, what you try to do is come up with some measure of benefits of say, a particular project opportunity, and then you divide that measure of benefits by some measure of cost. Now, by far and away, the dominant way we do this is to measure benefit in terms of revenue. If you're a for-profit organization, you do contract work for outside clients. Before you choose a particular project, whether or not to bid on it, you're trying to decide whether or not to bid on a project. Before you choose to bid on it, you want to see what are the benefits going to be. Okay, what's the cost going to be? And when you take a look at the benefit versus the cost, do the benefits exceed the cost? If it costs us more money to do the project effort than we get returns on this particular investment, then we don't want to pursue it. So what happens then is you have benefits divided by cost, and this enables you to compute a ratio. That's why I refer to it as the benefit-cost ratio technique. Very heavily used. It's been used for decades, okay, to help people prioritize different projects. Now, notice if your benefits are defined in terms of potential revenue, and then your costs are the actual project expenditures, a ratio of 1.0 takes on a special meaning. It's saying, let's say we estimate it'll cost $1.2 million to carry out a project. The revenue is also $1.2 million. That'll give us a ratio of 1.0. 1.2 million divided by 1.2 million gives us a ratio of 1.0. So the ratio of 1.0 is the break-even point. If our ratio is 1.0 or higher, we're going to break even or have more revenue than we spend money. Now notice if the ratio is less than 1, if you have a ratio say of 0.8, that's telling us that we're spending more money than we're generating revenue. By the same token, as ratios get larger and larger, especially when they're larger than 1.0, projects get more and more attractive. A benefit-cost ratio of 2.8 is telling us that for every $1 we invest in a project, we anticipate generating revenue streams of $2.80. So for every dollar we spend, we get back $2.80, okay, in terms of gross revenue. So benefit cost ratios provide us with a pretty good mechanism for rank ordering. Just through the number itself, we have a measure for rank ordering. Now, with any of these measures, you have to be very careful with any of these techniques to prioritize. All of them have their downside. All of them have their kind of pathologies as well as their strengths. And I think the benefit cost ratio illustrates this very clearly. Notice that if you have a ratio of 2.80, you have no idea how large the project really is. If I have a $10 project and it generates $28 of revenue, that's a ratio of 2.80. If I have a $1 billion project, it costs $1 billion to carry out, but it generates $2.8 billion in revenue, that also is a ratio of 2.80. So again, you have to be sensitive to the pathologies of any kind of measurement system we create, and when you're looking at a benefit cost ratio, make sure you ask people, what is the size of the underlying numbers? I don't want to be comparing a watermelon, okay, to a pea. And these ratios, if you're not careful, can do that. You really need to know the size of the numbers that went into computing the ratios in addition to the ratios to make informed decisions. Another thing, notice that these ratios don't tell us when payback occurs. Project A may have a ratio of 3.18. Okay, that sounds pretty good. For every dollar I spend, I'm going to generate $3.18 of revenue. Project B might have a ratio of 1.80. Okay, that's a lower ratio, doesn't sound very attractive. But if I don't get my money back on Project A for 5 years, and on Project B I get my money back within a matter of 6 months, clearly, even though the ratio is lower, I'm better off going with Project B, where I get my money back real quickly, than waiting 5 years to get my my money back on Project A. Again, that's another one of these pathologies that you got to be sensitive to. This doesn't mean that the ratios are no good. It means that when you get a benefit cost ratio, you've got to ask people, okay, I see the ratio, but when does payback occur? Does it occur in 6 months, 1 year, 2 years, 5 years? It's going to make a big difference in helping you decide what to do. So in general then, when you're looking at decision making, you need to focus your attention on prioritization, and you need to be explicit about it. Not just to intuitively start prioritizing things, but to develop some kind of an approach to help you prioritize in an explicit fashion. Before I leave this topic, for those of you who work on internal projects, it's estimated that in IT, for example, anywhere from 75 to 85% of IT projects carried out are projects satisfying the internal needs of organizations. Okay, they're not being contracted out to outside people, so they don't generate profit in an obvious, direct way. So you might say, well, you mentioned benefit cost analysis requires you to compute revenue divided by cost. On doing these internal projects, I don't know what the revenue contribution is going to be. It's an internal project designed to improve the business processes of the organization. For example, a new management information system. It's hard to track investment in that MIS to, does it increase profitability with outside sales? So can I use this benefit cost ratio? And the answer is sure. In fact, people in government face the same situation you're talking about, that you're facing here. That is, the government sponsors more projects than any other organization on earth, and they do benefit cost analyses with ratios all the time, even though they don't generate revenue. So if you're doing internal projects or if you're working on government projects, what you need to do in measuring benefits is not assess revenue, you assess cost savings. So the number you put up there would be, if I use System A, how much money will I save in comparison to using System B? So it's directly analogous to using revenue, but in lieu of using the revenue figures, you use cost saving figures. Okay, so start making better decisions, start making more informed decisions. And a good step to doing this is go out there, read up on decision-making tools and techniques that enable you to prioritize things more effectively on your projects. What needs to be prioritized? Well, in selecting staff, you need to prioritize that. Selecting vendors, selecting projects. Any decision you make at all, if you think about it, really does require a rank ordering of the options before you focus on a given option. What I'd like to do now is to talk about the most famous tools we have in project management, which are the scheduling tools. Now, there are many different ways you can create a schedule. When I'm scheduling my own work, I very often like to just use generate calendar pages and put X marks and identify when critical due dates arise. Frankly, on very small efforts that I carry out, that's good enough. On the other hand, if you're building, let's say, a major aircraft, a new generation commercial aircraft, sitting around filling in calendars isn't going to be a very good way to schedule that effort. And with something like that, it'll be obligatory, required, that you use more sophisticated scheduling tools like PERT CPM charts. Okay, PERT CPM charts, these were techniques developed back in the 1950s, and I always find this ironic because when people say, well, do you know the advanced techniques of project management like PERT and critical path method, CPM? And I'm not quite sure where they're advanced, and they certainly aren't state-of-the-art. These techniques were developed in the late 1950s. Are they useful? Sure, they are useful, but let's not confuse them. Let's not fool ourselves into thinking that these are really state-of-the-art advanced techniques. They're not. Okay, but they are important, and they're basically systems diagrams that show tasks. Okay, you lay out all these tasks, and today we represent them as boxes, and you show lines connecting the tasks. And if you got a large project, you might have 10,000 tasks in your PERT CPM chart. If you have a very small project, you might have 15, 20 tasks. But the point is, what the PERT CPM chart enables us to do is to create a systems diagram, a flow chart of sorts that shows how all the pieces fit together. Once you have your project laid out on something like a PERT CPM chart, you can do all sorts of what-if modeling analyses. Okay, what if I move these tasks around, carry them out earlier? What will that do to the overall duration of the project? Today, these PERT CPM tools are embodied in project management packages like Microsoft Project or Project Manager Workbench. Again, a couple of years ago I did a survey. I identified over 300 software packages out there that help project managers schedule their projects. So there's a lot of tools out there, and almost all of them not only allow you to create the PERT CPM chart, the systems diagram allowing you to model your overall project, but they also capture data on resources and costs. So they enable you to have an integrated cost scheduling resource tool. So if you've modeled your project and you ask yourself, what happens if I move some of these tasks earlier in the stream of activities, not only can you see the impact on the end date, but you can also assess its impact on resource requirements and impact on cost as well. Now, on many projects, in my opinion, creating something like a PERT CPM chart is gross overkill. It's like trying to kill a mosquito with a 14-gauge shotgun. So basically, one of the decisions we have to make is in trying to create schedules for our project, does the project we're working with really, is it so complex and so involved that it really requires all all the extra work that you need to put into creating a PERT CPM chart. And for example, if you have a 2-week project to develop some new item, do you really want to spend 1 week of the 2 weeks sitting down trying to create the perfect PERT chart? And I think the answer is, if you have any business sense, the answer is no. So what alternatives do we have to doing PERT network diagramming? And the most obvious alternative and the most heavily used scheduling tool on earth is the Gantt chart. Now, Gantt charts appear in many different ways. The most common appearance, though, is a bar chart. And so you have these bars associated with different tasks, and the bars go across a timeline. Okay, so you have time on the bottom axis, and the bar shows the start and end dates of the different tasks. And Gantt charts are so easy to use and so easy to interpret that they're a great communication tool. If I'm doing briefings to my management or my customers or my project team, and I want to show schedule status, I'm not going to show them PERT charts. The PERT charts would overwhelm them with boxes and lines. They're not going to make heads or tails out of it. Also, the Gantt chart enables you to have one bar. Let's say you can color code it. The one bar is yellow, represents your baseline, your plan duration, and right next to it you can have another one that's blue, that shows actual. So for all your tasks you can have yellow bars and blue bars, which enable you to look at actual versus plan. So it's a great control tool that's so easy to implement. Another one of the tools I think that's gaining in popularity is the milestone chart. And interestingly, milestone charts are being used increasingly to help senior program managers on multi-billion-dollar programs to keep track of what's happening at a high level. Okay, milestone charts are very good to get a big picture, high-level view of project progress. And milestone charts can also be used on very small projects. A $10,000 project can use a milestone chart as well. Now, what do milestone charts do? Well, like as with Gantt charts, you'll have a timeline going across the bottom of the page, and then you put little boxes against the timeline indicating when certain key milestones need to be achieved. Okay, so preliminary design review might need to be achieved by week 3. Critical design review needs to be achieved 2 weeks later, and so on and so on. So with the milestone chart, at a glance, you can see the key deliverables that we're producing on our way to producing the final deliverable of our project. So they can be used on very small projects, they can be used on large projects as well. One thing, if you're creative, you can use a milestone chart not only to look at your technical tasks, but you can use it to also factor in other things as well. I do a lot of work with the Defense Department, and a few years ago one of my students who used to run $300 million projects showed a milestone chart that he and his colleagues used in designing new ships for the Navy. And their milestone charts had 3 tiers to it. Okay, the bottom tier was the technical tier of doing project work. And at that tier you could actually have PERT charts and detailed Gantt charts and so on and so forth. That's the technical level, so key technical milestones, very detailed. At the top level, John showed me, he said those are the drop-dead milestones. They not only include very important high-level technical requirements, but they also include things like budget milestones that we have to be sensitive to. In many organizations, especially in the Defense Department, if you're a day late in submitting a budget request, you may find that your project's kicked out of the budget cycle until next year. Not only do they look at technical milestones, high-level technical milestones and budget milestones, they'll also look at paperwork milestones. We have to submit a certain report by such and such a date, and if we don't, our project might get kicked out. Okay, a lot of the people I work with also include political milestones up there. Admiral Huckenloffer is going to visit our site on the 13th of March. let's make sure that we have some deliverables to show the Admiral to impress him with how much progress we've made. So when you use milestone charts, you have tremendous flexibility to include technical milestones, budgetary milestones, other bureaucratic milestones, political milestones, and you can even color code them to let people see at a glance, without reading the detail, the nature of the milestones we're covering. So at the high level, there were the the high level organizational drop-dead milestones. At the bottom level was detailed technical milestones, and then in between, the middle level was what he called the program management level. That's where he and his colleagues had to figure out how to make the high level and the bottom level work together. So this was an intermediary level where I, as the program manager, I'm going to insist that the technical people get certain things done and the report gets in my hand before all this stuff has to be passed on to the higher people in the organization or customer, whatever. So those, I think, are the dominant tools that we have in scheduling: milestone charts, Gantt charts, PERT CPM charts. I want to say something. I want to give introduce an element of reality here. I've seen papers that have been published in respectable journals indicating that things like 60–70% of project professionals use PERT charts, and 85% use Gantt charts, and so on and so forth. I don't believe it. I didn't believe it when I saw the articles. I think the articles were focusing on organizations that require use of these tools and techniques. But I work with tens of thousands of project workers. Very few of them use PERT CPM day to day on the job. A bit more use Gantt charts. My reckoning, based on my experience and based on some research that I've come across, not my own research, is I think that probably 20% of project workers use Gantt charts. Okay, I've seen studies that tend to confirm that figure. When you're talking about general organizations, not organizations that are specifically adhering to specific methodologies that may require Gantt charts and PERT charts. And then by my reckoning, I think it would be a miracle if 5 to 10% of projects carried out worldwide actually use PERT CPM charts. So that's what I call my dose of reality. I have people all the time saying to me, well, I can't see how you can manage projects without using Microsoft Project. I can see it. I see it all the time. And one of the things we have to recognize is that there's more to project management even than using these particular tools. Still, I wish more people were aware of the tools. I do wish they were used more heavily. I'm not proud of the fact that the use is as low as I suggest, but I also I'd be very surprised, and I think it'd probably be overkill to have 85% of our projects or 80% using PERT CPM when they're just not large enough to warrant the effort. Let's now look at cost management tools. In the arena of cost management, the Project Management Institute, who is the organization, the global organization that establishes many of the project management standards that we live by, recognizes that cost management has a number of components to it, including cost estimation, including budget processes, including certain basic finance, like doing present value analyses, and including cost control. So when we talk about cost management tools and techniques, there's a whole bunch of these tools and techniques that we can draw on from different disciplines, from economics, from accounting, from finance, from budgeting, and then unique tools that we've developed within project management itself. I'm going to just make, in discussing cost management tools, I'm just going to make a couple of brief points, and then I'm going to be done with it. One thing that we should be aware of, and I had mentioned it in a previous session, and that is that in many organizations, they don't have cost data. They don't have data on what it costs to do a job. I had done a survey back in a few years ago of a fairly substantial number of project professionals, and only 30% indicated that on their projects they had usable cost data. That means 70% were flying blind from a cost management point of view. So one thing we have to recognize when we talk about cost management tools and techniques is that many of us find ourselves in a position where we just don't have the cost data to do good cost analyses. Now, if you don't have cost data, dollar data, if your organization isn't supplying this, then don't give up. The Defense Department showed us several decades ago that if you don't have dollar data to help you do cost analyses, you can create your own budget using something called level of effort. So 2 people working 10 days on a task reflects 20 person days of effort. Okay, 5 people working 4 days also represents 20 person days of effort. And if we know what these people, what they cost us to employ them on a per day basis, if I have 20 person day effort, effort that I'm looking at, and each person is costing us $100 a day, okay, that's $2,000, okay, so that's $2,000 that we're spending for the 20 person days of effort at $100 per person per day. So we can reconstruct budget data if we're able to compute level of effort. One financial services organization I've worked with, based in Wall Street, estimates that IT professionals, the cost of employing IT professionals in their downtown Wall Street operation is $200,000 per person year. That's not the salary. They're paying a lot of rent and overhead down in Wall Street, but the cost of employing an IT professional in the New York City operation is $200,000 per year. So all of their budget estimates are based on fractions of a year's effort that a particular project may entail. If a project entails a fourth of a person year of effort, then the dollar budget for salaries associated with that using IT people would be $50,000. That's a fourth of $200,000. If it involves 1.5 person years of effort, then the budget estimate there would be $300,000 for the cost of doing the effort. Okay, so that's the level of effort budgeting, and all of us can do it if in the unfortunate circumstance that our organization doesn't provide us the data we need. Even when we do have cost data, you've got to be careful. If you notice, my question was, do you have useful cost data? Cost data you can use to help you manage your projects. And the problem was that many people reported having cost data, but it wasn't useful. It was developed for the convenience of the accountants and for reporting data to the Internal Revenue Service. It wasn't geared towards tracking project progress as a project migrates its way across different departments of an organization. So in cost management, using tools and techniques, one thing that's become apparent is that to have effective cost data for project tracking and task tracking purposes, you need to operate in an environment that supports ABC accounting systems. ABC stands for Activity-Based Cost Accounting Systems. And this is a big movement in many companies. Many companies who operate with general ledger accounting systems are also adopting parallel ABC accounting systems, because with ABC accounting you can actually track costs associated with the task as the task moves across the different departments within the organization. Whereas traditional accounting is just reporting data on a department by department level. So that's something else when we talk about tools and techniques of cost management to be aware of, that the tools and techniques if you actually have cost data that's supplied to you by your organization, that you want to be pretty sure that the cost data allows you to actually track tasks instead of just aggregate data on a department by department basis. The tools and techniques that you can use to project costs, the most famous one is called a cumulative cost curve, also called an S-curve. Now, what it does is it takes a look at your monthly budgets. Let's say if you're projecting costs, and budgets month by month go up and down, up and down, up and down. Some months we spend more, some months we spend less. And it's very hard when you look at a chart that has ups and downs like that to be able to see basic trends. So with the cumulative cost curve, what you do is you take those ups and downs, the monthly expenditures, and you accumulate them. You add month 1 to month 2, then you add that accumulated figure to month 3, and ultimately it creates a chart that assumes an S shape. We call it the S curve. Okay, the cumulative money being spent over time. And the beauty of the S curve is that, as with a Gantt chart, it becomes very easy to compare the cumulative plan budget against the cumulative actual. If the actual lies below the plan, you're spending less money than you planned. If it lies above the plan, you're spending more money than you planned. So I think right now, if you're talking about tools and techniques, what's vital to use to help you manage your projects better, I think 2 tools and techniques really stand out. One is the Gantt chart, which we talked about when we talked about scheduling tools and techniques, which very easily allows you to compare actual versus planned task duration allocations. And then the S curve, which allows you to compare actual versus planned cost allocations very, very quickly. So I can do integrated cost schedule control just looking at these 2 charts, the S curve and the Gantt chart, and I can see I'm behind schedule but under budget, okay, or I'm behind schedule and over budget as well, or I'm right on schedule but I'm over budget. So by looking at these graphic portrayals of schedule and budget performance, it'll help you instantly assess integrated cost schedule status. Also, it's a great communication tool to communicate to your customers, to your managers, to your employees. So they can know very readily, without going through a project management course, what the status is of the project that you're working on. Let's now look at the tools that are commonly used in planning and controlling human and material resource allocations. The first tool that you should be working with when you begin the process of trying to identify resource requirements for a project is a very simple but powerful tool, and you really must use it. If you aren't using it now, start using it. And it's called a responsibility chart, also called the resource matrix. What a responsibility chart does is, across the top, it identifies, okay, resources who could be applied to the project. Along the side, it lists the tasks that need to be carried out. So fundamentally, you have a grid, resources on the top, tasks along the side, and then you just ask yourself, to do task A, what resources do I need? And you can put little check marks into each of the boxes. Okay, what resources do I need to do task B? So this chart here enables us to see who do we need to do what work. And it doesn't involve use of major computer algorithms and so forth. This can all be done in the back of an envelope. Very useful in getting your first sense of who do we need to do what kinds of work. Some people like to code instead of putting check marks, they like to put in some coding system indicating the role, the responsibility of the resource. And the most popular coding system I call the PAR, P-A-R, where you put a P in there if the person is supposed to perform work on the task, A in there if the person's supposed to approve work on the task. You put an R in there if the resource's job is to review the task effort. Again, whether you use coding, special coding, or just check marks is really a matter of indifference. It's important, though, if you want to get your arms around the resource allocation issue, that you start off by creating a chart like this. Okay. Other charts that are used frequently to help plan and control resource allocations are charts like the resource Gantt chart. Earlier we talked about a task Gantt, which shows a bar chart, which has a bar chart showing with a bar the duration of tasks over time during the life of a project. With a resource Gantt chart, instead of showing bars representing tasks, you have bars representing resource allocations. And as with the task Gantt chart, it gives us an instant view of what our resource allocations are. We can also use it to compare a plan versus actual. The most famous resource allocation tool is called, we used to call it in the old days the resource loading chart. Today we call it the resource histogram. And what it does is, on the bottom you have time, you have a timeline, and what it does is it shows week by week how many resources do we need. So on the y-axis we're measuring the number of resources planned to be used, and then on the x-axis we have different time periods. So the resource histogram is an actual portrayal of the profile of the project. When a project begins in the early stages, the number of resources required might be fairly small. As a project builds up and more work is carried out, then the resource histogram gets higher and higher. Okay, and then as a project winds down, you'll see there's a decrease in the number of resources needed to carry out the work. To get better insights on the use of all these tools and techniques, you should look this up on the web or in a book. I describe all of these in some detail in these two books. Managing Projects and Organizations focuses on the very basic tools and techniques, and then the book here, the New Project Management, gets into more advanced tools and techniques that can help you plan and control your projects more effectively. Let's take a look at tools and techniques that fall into what I call the softer range. As we've seen elsewhere in this program, projects, a leading source of problems on projects is managing needs and requirements, getting needs and requirements right, which means first of all, we have to know who our customers are, and then we have to be able to try to decipher what they're telling us their needs are. Then we have to observe them physically in operation as they're working to make sure that what they told us their perceived needs are really reflect what we see there needs to be by observing them in action, these kinds of things. And a number of tools and techniques have developed primarily in the IT arena to help us do a better job of capturing customer needs and wants. Now, the big challenge we have, especially in dealing with knowledge-based projects, is trying to bridge the gap between business users and technical team members. Certainly this holds true in IT projects and telecommunication projects, but even on projects in basic construction. You'll have customers saying, well, I think I need this, and then the carpenter hearing what carpenters hear, that kind of a thing, and there may be a big gap. So it's become apparent in recent years that if we're going to have customer satisfaction with our projects, we need to do a better job of capturing their needs, their wants, and converting them into requirements that the technical team can use to design solutions and implement solutions, okay, through project management. Now, as I mentioned, the IT industry has been struggling with this problem of bridging the business technology gap for a long, long time, and they've developed a number of tools and techniques that are quite helpful in helping us to enabling us to get technical people to develop a better sense of customer needs and wants, and enabling customers to develop better capability of defining their needs and wants so technical people can understand them. A whole bunch of tools and techniques have arisen here. Things like entity relationship diagrams, context diagrams, environment process diagrams, flow charts, and all that. I just want to discuss one technique that is useful for anybody doing project work and is very useful in particular for IT projects. And the technique is called JAD sessions. Okay, JAD stands for Joint Application Development. IT people have been using JAD sessions for quite a while. They're not brand new, but they're not ancient either. They haven't been used forever. They've been used for in the fairly recent past. And what you do with the JAD session is you recognize that if we're going to capture requirements and needs properly, we need to bring the customers and technical team members together. So with a JAD session, we put we have a cross-functional group of a range of customers and some key technical people. We bring them into the room and then we lock the doors. Okay, so we don't let the people out until they have a chance to come up with a set of needs. During the course of the day, there's a facilitator who works with the customers and the technical team members, and they have to come up with a set of needs by the end of the day. Fundamentally, I like to joke, what you do is if you're a good facilitator, you tell them all the oxygen will be out of the room by 7 p.m. So if we don't come up with a good set of needs by the end of the day, we're all going to die. So basically, what you're doing is putting a lot of time pressure and trying to get people to focus on the real key issues. So they make a lot of use of post-its in trying to define needs and grouping the post-its in intelligent ways, and the technical people and the business people start working together shoulder to shoulder. If there are items that we can't achieve agreement on, what you do is you don't sit down and try and debate it. We don't have enough time. Those items go on to the what's called the parking lot. They go into a parking lot. And what will happen is when the JAD session is over, a post-JAD group, which will be comprised of a smaller group of people from the JAD session, will meet afterwards. And then they will decide how to deal with these issues that couldn't be resolved in a post-JAD session. So very often you'll have two JADs. The first JAD gets a high-level needs. The second JAD will take the results written up by the post-JAD team, and they may spend a month working out the details of trying to capture what occurred in that one-day session. And then that becomes the input for JAD 2, where you go into more detail on needs and requirements, use the post-its, and put things in the parking lot that can't be resolved. That'll have a post-JAD session 2. The post-JAD session writes up its report, submits it to the project sponsor, and fundamentally, through a process like this, we have some assurance that we put the technical people and the business people together, and that there is some consensus on the direction we should take in defining what our needs and our requirements are. So in a very compressed period of time, we've taken a blitz, super quick overview of some of the key issues in planning and control tools in project management. Clearly, to have mastery of these tools, one needs to do a lot more investigation and practice, practice, practice. Ultimately, if you're going to be good at something, you've got to go out and use it. You have to practice with it. Now, having gone through a discussion of tools, I do want to go back and just remind you of something I said in the introductory comments, and that is ultimately your projects are not likely to succeed and fail because of your ineptness or mastery of tools and techniques. Certainly things like people issues are going to be much more significant in determining the levels of success you have and the likelihood of failure. If you have a bunch of people on the team who hate their jobs, who don't want to be there, no matter how many great tools you have them use, you're going to find yourself struggling to be successful on that project. Now, in the program that we have here for managing projects and taking an overview perspective on managing projects, we've covered then different elements of project management, including tools and techniques just now. We've taken a look at the environment. We saw that the environment is a difficult one. We look at soft skills and recognize that it's not enough just to have the hard skills. The soft skills are very important as well. So all these things taken together, competence and so forth, all these things taken together are what ultimately enable us to be successful